Good morning, everyone. Thanks for coming. And yeah, it's me again, Joshua again. Today, I'm going to introduce the MPPT and solar panels to you. Okay. Thanks again. Thanks again. Thanks for your coming. Okay. Let's go straight to the point. Okay. First, let's see the content of today's live streaming. Our content will be 6 parts. The introduction of the solar panels and the configuration of panels and MPPT, and also our Felicity Solar MPPT, the PV combiner box, and the warning code and full code explanation. 听不到声音。那个蓝牙点一下。Okay, let's go. Let's go into the first part, our solar panels. Yes, and maybe some dealers may know our products. Our panels are divided into 2 parts. Yeah, 2 different parts. You can see the left side is these panels. They're divided into 2. This one is called the half cut, and the right side is the full size. And the advantage of the half cut is it can generate less heat, it has higher efficiency. And you can also see from these 2 charts, all of them are monocrystalline, and the MSD 100, MSD 108, all the MSD is the half cut, and the M series is the full size. And you can see the rated maximum power is the 350, 400, 450, 540, and you can also see the 100 from 100 to 325 voltage. And you can see and next is the dimensions, the weight, and the maximum power voltage, the VMP, maximum power current, IMP. And you can also see the open circuit voltage, the VOC, and the short circuit current, the ISC. And this chart, the most important 2 data is the ISC and the VOC, because these 2 data is related to the configuration and the calculation of the power. This data will conduct us how to connect our panels. Okay. Yes, so that's the solar panels. And next, we're going to talk about our MPPT solar charge controller. The first, you can see it's the present MPPT solar charge controller. And now we have a new. Yeah, we need some help from our system. Okay. This one will be like this. This will be better. Okay. Okay, let's go on. We have a new MPPT solar charge controller. Yeah, that's it. You can see the difference. So the biggest difference of the MPPT solar charge controller is you can see the outlook is totally different, and also the button. The button is the pressed button, and the new version is the touch screen, just like your cell phone, the touch screen. And this model is called the 2nd generation of SCCM series. let's take something. Let's take an MPPT solar charge controller for instance. So you see the let's see the SCCM 3024 the second. You can see some data. The maximum battery current. Yeah, the maximum battery current is 30 amperes. And this MPPT solar charge controller can be used in two kinds of voltage system. The 12 voltage DC and the 24 voltage DC system. Yeah, it can be used in these two. So, and the maximum solar input voltage is 95 voltage. So this show indicates that your solar panels, if the solar panels voltage is more than 95, this system will not work. Yeah, and also the start voltage, the PV start voltage is 15. So, for example, in the morning, when there is no sun, the light is dim, the night is not strong, the voltage may be less than 15. So, in this time, the MPPT won't start until the light becomes stronger. So the voltage will be more than 15. So the MPPT will start. So that's the startup voltage. And the PVRE MPPT voltage range. There's two parts, the 12 voltage system and the 24 voltage system. For the 12 voltage DC system, the current, the voltage of the PV is 15 to 80 voltage. In the 24 voltage battery system, the voltage of the MPPT of the solar will be 30 to 80. And in the last part of this chart is the maximum input power. So in the 12 voltage system, the maximum power is 420 watt. But in the 24 voltage system, the data will double. Now it's 830. Yeah, that's the basic data. So let's take another example. The SCCM 148, the second generation. You can also see the maximum battery current. They are 100 ampere, and differently, it can be used in three kind of voltage system. The 12 voltage system, the 12 voltage system, 24 voltage system, and the 48 voltage system. And you don't need to adjust it. It is auto detection. Yeah. For the SCCM 148, the maximum solar input voltage is 195 voltage. So generally, if you connect the 450 watt power panels, the voltage of this kind of panel is no less than 50 voltage. So which means that you can connect about 5 and maybe you can connect 4 parallel, 4 in series. Okay, and why don't you just look at me? Yeah, and the PV start voltage is still the same, the 15 voltage, and you can see that for the different voltage system, They have different power. For the 12 voltage system, the maximum power is 1375. For the 24, the data will double, and then for the 48, the data will double again. So the maximum power will be 5500 watt. So that's the MPPT solar charge controller. That's the basic data of them. So next, we're going to talk about the Felicity Solar built-in MPPT inverter series. The first one is the IVM, our high frequency. Because the high frequency inverter has the built-in MPPT, so let's talk about it. You can see the data. Let's take the IVM 5048 for instance. The maximum PV open circuit voltage is 500 voltage, and the PV working range voltage is 100 voltage to 500, 120 to 500. So for the different voltage and the different current, the maximum input power will be different too. The maximum input power of the IVM of the MPPT built-in IVM 5048, the maximum power is 6,000 watt. And for the max input current, the max input current is the current from the panels is 20 ampere. Which means that, so if the ampere is more than 20, the PV will not work. This machine will start work, will give some error code. The last part is the minimum start voltage. Is 125 voltage. This voltage is high. So in this, for example, in the morning, in the rainy day, or in the early morning, maybe the machine will not start work because of the voltage is lower than 125. So when you face this condition, don't worry, it is normal. So except from our high frequency inverter, it has the built-in MPPT solar charge controller. Our power frequency inverter IVPN also has the MPPT solar charge controller. Yeah, that's the parameter. The basic parameter has the same essence. Also the VOC, the maximum open circuit voltage, the PV working range, the max input power, and the max solar charge current. So what is different is the voltage and the current. And for the IVPN, the built-in MPPT, the voltage is lower, is 195 voltage DC. But for the current, the solar charge controller current of the IVPN is 120. The maximum is 120. So for the different current, the power is also different. It's 6,600. Yeah. So that's all for the MPPT. So for the MPPT of Felicity Solar. After that is the configuration of the MPPT. We know some data just to conduct us how to connect our panels and how to match our MPPT solar charge controller. So But before that, we need to figure out two questions. What's series and the parallel mode? What are they? And how to calculate the number of the solar panels when they are connected in series and parallel. The first question is simple, and maybe all the dealers know. It's just some basic physical knowledge. So it is simple. When you connect the panels in series, the current will stay the same. The current will stay the same, but the voltage will be different. For example, if you connect three panels in series, your voltage will be tripled, just times 3. The voltage will be 3 times of its original. If you connect 5, the theta will be 5 times of it. But differently, if you connect the panels in parallel mode, your current will be different, just like the voltage. So if you connect 5 panels, the current will be 5 times of it, 5 times. But the voltage will still be the same, will keep the same. Yeah, that's it. That's very simple. And next question, how to calculate the number of the solar panels when connected in series and parallel? So why? Because we want our panels they can generate the power. We just don't want it to not surpass. We just want it not surpass the limitation of our machine, just to protect our machine. Okay, so to ask this question, we need to get 3 crucial data. The first one is the PV input power, especially the max PV input power, and the next is the voltage open circuit. And the third one is the short circuit current. Okay. For example, let's give you some its existence. You can see that from this picture. This is the IVEM, our inverter. It has the built-in MPPT solar charge controller, and the right side is the basic data of this system. You can see there are 8 panels. The 8 panels, each panel has maximum 450 watt power. That's the data. The IAC, the short circuit current, is 11.9 ampere, and the VOC, the voltage open circuit, is 47 voltage. And we can calculate the input power. The input power that generated from these panels, the max input power, is 450 times 8. That's 3,600 watt. And that's the data. That's the max power these panels can generate. And the next, the below is the data of the MPPT solar charge controller of the IBM 5048. You can see the maximum voltage, the maximum VOC of PV is 500. The maximum input power is 6,000. The maximum input current is 20 ampere. So you can see that this IAC is smaller than 20. This voltage, the 47, because you can say 47 voltage, you can times 8 is less than is less than 500 voltage. Okay, and the maximum input power of these panels, there are 3,600. It is less than 6,000. So when all the conditions are needed, when all the conditions meet the needs of the MPPT solar charge controller, so that it is suitable for this. So all the so we need to make sure that all the data of them must be smaller than this data. Okay, that's the example. So after that, we're going to talk about the PV combiner box. PV combiner box. So why do we need the PV combiner box? Just like the battery combiner box we mentioned in the last live streaming, just for the safety. Yeah, just for the safety. Yeah, firstly, we're going to introduce some the basic data of the PV combiner box. The maximum input PV voltage of the PV combiner box, it is the same, the 500. So what is different is the maximum number of input paths, 6 and 8, and other data is also almost the same. Okay, so the biggest difference, the PVCB, the PV combiner box 6 to 1 and 8 to 1. Yeah, you can see there are six input and 6 output. Six input positive and 6 input negative, and the output will be there. When all the PV their cables. And all the PV cables connected from there. Yeah, is that right? All the cables. Yeah, that's the positive, and this is the negative. Yeah, that's the 6 to 1 PV combiner box 6 to 1. Yes, these are the cables. They are connected. They are the cables from the PV, and they are connected in there. Why? I don't know. They're connected from there, and this is the output. Just like this, you can see that. That's the positive and the negative. The cables will be out there. Let's show you some examples, some pictures. You can see that in this system, the panels, there are 12 panels, and the panels, well, that's strange. And the panels, they're positive and negative, because there are many 10 terminals. There are 4 terminals that be connected in there. Because the MPPT only has the one positive and the one negative PV input. You need to connect all the terminals, the positive and negative, to one, to converge them, and then let them flow from there to there. And also, it's the same. All the positive and negative terminals, they be connected to there, from there to there, and they be converged to the terminals, to the input the PV input positive and negative. But not all the PV combiner box is not always necessary for the system. For example, in this system, in our IVEM, this is the high frequency IVEM series. All the panels, they are connected in series. So only one positive and only one negative are needed. So you just need them connected. So they're just the one positive to negative and negative. So the PV combiner box is not necessary. Yeah, that's it. But for our power frequency, or if you have more panels like 20 or 30, you need the PV combiner box just for the safety, just like this. You needed more panels or more terminals. Yeah, that's it. So after we just introduce our PV combiner box and MPPT, we are going to talk about some warning, some MPPT warning and the fault code description. Just to give you some example, just to show you how to just to show you some the data, some cases you need to pay attention to. Yeah, some is very easy just because of the uncontrollable weather, but it's not fault. Okay, for example, in a fault code, if MPPT, yeah, the MPPT is showed the O3. They showed O3, which indicates that the battery voltage is low. So how do we connect? How do we check out this problem? Just to check, we need to check if the battery has the output voltage. If the battery has the output voltage, that will be the problem of the panels. Okay. We need to check the battery. And if the MPPT shows 0.5, which shows the PV voltage is too high. In this case, we need to check the voltage of the PV. We need to use the multimeter to check the voltage of the PV, just to check from the positive and negative terminal. Just check if they are in the limitation. If they are in the limitation of the MPPT solar charge controller. And that's the fault code. For the warning code, the 20, which shows that the PV voltage is too low. This will happen in the morning, and especially in the morning or in the after the sun sink and before the sunrise, because the light is dim, so that the panels can't generate enough voltage for the system. So the machine will show some problem, will show the 20. But when the sunrise or when the light is stronger, this problem will disappear. And for the code 21, which shows that the output derating caused by high PV voltage. And this is, when this happens, you need to check. We need to check with the multimeter to check the voltage if it is too high. Yeah. And that's the warning code and fault code, and some solutions you need to do. And the last is about the note. We need to pay attention to this note. When we connect the panels, only one group panels only connect to the one inverters. Yeah, that's it. One group match one inverter. One group in panels match one inverter. Don't connect more than one inverter with one group of panels. Sorry, this is type wrong type. This is called the PV. Okay, and the next is the input voltage of PV is not allowed to surpass the limitation of MPPT solar charge controller. For example, this is the IVEM 5048. Its limitation is 6,000. The MPPT solar charge controller is 6,000 watt. So when your panels, the power generated by the panels is more than 6,000, this machine will start to show you some the code, like the voltage is too high. They will show this because there's too much power. The machine can't bear this, and they can't bear too much voltage. This will cause some damage to the machine. Yeah, that's it. You need to pay attention to that. And number 3, don't connect positive and negative wrongly, because in some countries their positive power cable and negative cable, they're the same color. Maybe all of them are red or are black or are blue or something like that. You need to pay attention to that. So, in our inverter MPPT solar controller, we have the positive and negative signs. Okay, see that? We have the positive and negative signs. Yeah, you can see from the picture. Yeah. For example, if to avoid this, in this case, we have some signs on the bottom of the MPPT solar charge controller. We have the positive and negative signs on the bottom, and this is the size and this is the sign, positive and negative. Yeah, to avoid these questions. Yeah. Yeah, that's and the left side is the MPPT, the PV, and the right side, positive and negative, it is for battery. Yeah, it is for battery. Oh, sorry. And it's wrongly typed. I'm so sorry because it's wrong, because this one is the positive and negative. Yeah. Sure. Yeah, that's it. So yeah, that's all